Okay, the distance traveled between Northridge and Santa Monica is 20 miles. If it takes you 20 minutes to go from Northridge to Santa Monica and then another 40 minutes to come back to Northridge, what's your average speed for the whole trip? So speed is distance over time, which is different than if they'd asked for the velocity of the trip.
Okay.
The answer would have been 0.
Okay.
Because velocity is displacement over time, and your net displacement would have been 0. Okay, so your overall distance is the 20 miles to Northridge and the 20 miles back, which is 40 miles. And then that takes place over the course of 20 minutes plus 40 minutes, 1 hour. So 40 miles per hour. Number 2, a car is on a road and acceleration is applied in a direction perpendicular to the direction of the velocity. Okay, so the object is maybe going like this way with this kind of velocity, but then it begins to accelerate this way. Is that all right? Okay, so that means, okay, so, and it says that this is the x direction for the velocity and this is the y direction for the acceleration. So what conclusion can be made about this scenario to solve a problem? The x component of the car's velocity stays constant. That's true. Because there was nothing that accelerated it in the x direction.
Okay. Okay, that makes sense.
The y component stays constant? No, because something accelerated it. The velocity of the car stays constant? No, in fact it goes faster because it has this velocity component.
Plus that one.
Plus it's gonna get some velocity this way, so it'll be more. The car is speeding up. Well, yeah, that's also true. Actually,
I have all the answers.
What conclusion? You know what? I guess the car doesn't have to be speeding up. Like it could be going in a circle where, right, like if it's going in a circle, then the velocity down here goes like that and the acceleration goes up. And that could be moving at constant speed. So
that's well,
that'd be moving if it's just say it again.
Would that be centrifugal acceleration?
Yeah.
Okay.
So I don't know. That's the answer. Okay, number 3. 6 vectors are pictured in the figure. Which of the following statements is false? Okay, a plus b is negative e. So a plus b
I don't get this. I don't get how this works.
So all that you have to do is go butt to tail, right? So like a plus b literally means take b and tack it on to wherever a stops. So a plus b literally means this.
Okay.
So from where I started to where I finished, which is true because that's the opposite of E, right? Like E does that exact thing, except it does it the opposite way. So that is a negative E. So this is good, right?
Yeah.
D plus E equals C. So D plus E equals C. Yep.
Okay.
Right. So E tacked on the end of D, and then it's butt to tail. So
okay, that makes sense.
This is good. C minus A. So C minus A would look like this. Here's C, right?
Mm-hmm.
And then if A goes this way, negative A goes the other way.
Okay.
So this is C, and this would be negative A. So C plus negative A is the same thing as like C minus A.
C.
Right, like 2 minus 4 is the same thing as 2 plus negative 4. So that's all I'm doing.
Okay.
So I'm doing C plus negative A. is supposed to equal E. Well, it equals this thing, which is E. Yeah, it is E. Yeah, that's E. So this one's good. D minus B. So D, this is D, like that, right? Minus B. Well, positive B goes up, right? Positive B goes up. So negative B must go just like the opposite way, down. This is negative B.
Okay.
You just flip it. So that's D plus negative B. And then you get something like that, right?
D plus negative B, okay.
Which would be a negative F. Oh, so this one's wrong.
That's the wrong
And
one.
then B plus E equals negative A. Yeah. So B plus E it does equal negative A, right? So B plus E,
and then, well,
like, okay, so B was this upwards thing, E is this, and so it equals this, which is the opposite of what A is doing. So that's negative A.
Negative?
Yeah. Okay. And then number 4, 2 golf balls are simultaneously hit in different directions so that they reach the same height above the ground, as shown in the figure to the right, with their paths labeled 1 and 2, which of the following is false? Both balls hit the ground at the same time. Yeah, that's true. Oh, oops. Shh. Are you serious? Hold on. Don't worry. We'll bring it back. How'd that happen? I don't know.
I like that frame rate lag.
Close enough. Okay. So since both balls get to the same height, they must have both had the same y component when they started off.
Yeah.
They're both, even though like the black one had
a different angle.
Like a different x component of velocity, which creates the different angle, which makes it go further.
Yeah.
But they're both in the air for the same amount of time. So this is true, right? The x component of the initial velocity of ball 2 is larger. We just got done saying that, right? The y component of the initial velocities of each ball are the same. We just got done saying that. Ball 2 travels further due to more acceleration in its projectile path. No, it has the same exact amount of acceleration as the other one.
That's for the next one's. Wait, so that's the false one?
This is bad. Oh, yeah, right. That is false, right? I just said no, and then so that's false. And then the initial speed of ball 2 is larger. That's true because the x component's bigger. So that's it.